Hey, this is Mr. A, and this is Pre-AP Chemistry, Unit 7, Molar Calculations, Week 13. What are we going to do in Week 13? Well, in Week 12, we started this mole concept and looked at how moles and molar mass and particles all come together. Well, in Week 13, we're going to be taking a look at what's called percent composition by mass and empirical and molecular formulas. So the first thing is a percent composition by mass. What is any percent? A percent is part over whole. So if we want to find the percent composition of carbon dioxide by gas, I'm trying to find the percentage of carbon, which would mean that I could know the grams of carbon over the grams of carbon dioxide. Now, do you see how they haven't given me grams? I don't know how many grams of carbon are in carbon dioxide. I don't know how many, to find the percentage of oxygen, how many grams of oxygen are in grams of carbon dioxide. But what do I know? I know how many grams per mole of carbon are in grams per mole of carbon dioxide because I have a periodic table. I know there's one carbon, which means there's 12 grams per mole. Out of the total, if you add up the whole molar mass, is 44 grams per mole. And so if you take 12 divided by 44 and you times by 100%, that gives me a percentage of 27.3% of the compound is carbon. Which means if you know the percentage is carbon, if you had a 100-gram sample of carbon dioxide, 27.3 grams of it is carbon. Again, it's a ratio. If you only had, let's say, 20 grams of carbon dioxide and 27% of it is carbon, it's almost a quarter of it is carbon, isn't it? And so you can see how this percentage can work with anything. It doesn't, percentages don't have to be out of 100, okay? It can be, it's just a part of a whole, which means, think about it, you have two oxygens, each oxygen 16 grams per mole, which is 32 grams per mole of oxygen out of the total of 44 grams per mole of carbon dioxide. If you do that on your calculator, 32 divided by 44, and you times by 100%, you end up getting 72.7% of the mass is oxygen. Yes, those percentages add up to 100% because that gives you one total amount of carbon dioxide. Now, you can see we can find percentage composition by mass using the molar masses. We can also find the percent compositions by mass using mass, can't we? We have 18 grams of carbon. So if I want to know the percentage of carbon, well, we had 18 grams of carbon in a total of 22 gram sample of CXHY. I don't know how much carbon and hydrogen I have, but I know 18 grams of it is carbon, which means 18 divided by 22, if you times by 100%, that gives me 81.8% of the compound is carbon. Most of it's carbon, isn't it? Which means how much left over is hydrogen? Well, if 18 out of the 22 is carbon, then 4 grams of hydrogen out of the 22 grams of CXHY, the hydrocarbon here. 4 divided by 22 times 100%. Ends up being 18.2% of hydrogen. So you can see just a small percentage is hydrogen, which means, guess what? If we have a 50-gram sample of this, we can know how many grams are in each. We can know many, many different things. So I can find percent composition by mass by doing the molar mass ratios or the grams ratio, but it's always part over whole. Well, if you know the chemical formula and we can know the percentages, then if you know the percentages, can you know the chemical formulas? Yes. And that's how we find what's called the empirical and molecular formulas. The empirical formula is the simplest whole number ratio. The molecular formula is the true formula. And the formula is just a ratio of moles. That's what I want you to really get out of this entire kind of unit here. And it will be rather easy then if you think of it. Well, if we know 40% of this compound is carbon, then you can think of it as 40 grams of it is carbon, because remember, this is a composition by mass. We know 6.67 grams of it is hydrogen, and 53.3 grams of it is oxygen, okay? Now think about it. What do we do when we have grams? We always divide by the what? By the molar mass, because there's 12 grams per 1 mole. And think of it, if a formula is a ratio of moles, I want to get into moles. I want to figure out how many moles I have. So 40 divided by 12 is 3.33 moles of carbon. Hydrogen is approximately 1 gram per mole, which gives me 6.67 moles of hydrogen. And oxygen, we're going to divide by 16 grams per mole, and we get 3.33 moles of oxygen. Okay. Now remember, a formula is a ratio of moles. Now, can you see the ratio of carbon to hydrogen to oxygen? You can probably see it's a 1 to 2 to 1 ratio. If you don't see it, divide by the smallest one. So we divide every single one by the smallest one. So that's a little trick to the trade. So that gives me 1 carbon, 2 hydrogens, and 1 oxygen. So my formula is C1H2O1, but that is what we call the empirical formula. That's the simplest whole number ratio. So your percentages simply give you the empirical formula, the simplest whole number ratio. In order to know if this is the true chemical formula or the molecular formula, the true formula, I got to take a look at the molar mass. So if I take this empirical formula as molar mass and add this up, 1 carbon, 2 hydrogens, 1 oxygen. That's 12 plus 2 plus 16. That gives me 30 grams per mole. So the empirical formula has a molar mass of 30 grams per mole. The true formula, the true molar mass, is 60 grams per mole, which means what can you say about the true molecular formula is it's got to be double this, doesn't it? It's got to be C2H4O2. It still has the same ratio of a 1 to 2 to 1 ratio. But this is the molecular formula. This is the true formula of this compound. So if you want to find the empirical formula of any compound, you're looking at the ratio of moles. If you have percentage or grams, divide by molar mass to get the number of moles. If you already have the moles, just look at the ratio. If you don't see the ratio, divide by the smallest one. That gives you the empirical formula. If you want to know if that's the true formula, remember the empirical formula is just the simplest whole number ratio. You have to compare the empirical formula's molar mass to the true molar mass to get the true molecular formula. Well, guess what, guys? That was week 13, unit 7, molar calculations for pre-AP chemistry. I'm Mr. Ayton, and I'm signing off. Peace out.